All right, here we go for the last section of Unit 6, Properties of Similarity. Now, we need to take a minute and go back and review the triangle mid-segment theorem. This is an old theorem that said that the mid-segment of a triangle is parallel to one side of a triangle and its length is half of that other side. But we were always more interested in the fact that B was the midpoint and D was the midpoint. And so we had these equal segments, and that was always very powerful to us. I want to bring that out because that is different than the theorem we're going to get right now, which is the triangle proportionality theorem. These two are converses of each other. On your reference sheet, I've lumped them together as an if and only if statement. So we're talking about a line parallel to one side of the triangle, and it divides the segments into proportional lengths, not equal, proportional. So we have the parallel, and instead of having equal here, because these are not midpoints, what we get is a set of proportions that ny is proportionate to nb at the same rate that yj is proportionate to jk. Now there's a caution here. And that is to be sure to always be comparing segments to segments, because we've also seen this exact same picture where we've compared small triangle to large triangle. And you're going to see an example later where that illustrates that these are two separate things and they do not have the same ratio. Okay, so make sure you're comparing exactly the same thing. Another important theorem is the proportional parts of parallel lines. Proportional parts. So if three or more parallel lines intersect two transversals, we're talking about 5 lines total, then they cut off the transversals proportionally. So that means that this little segment EF is in the same proportion to DE as the transversal over here. BC is to BA. You could also write it as EF is in the same proportion to BC as DE is to BA. Again, you're keeping the same transversal either together in the numerator, together in the denominator in this example, or you're keeping the same transversal together in one fraction with equivalent pieces in the other. When you cross multiply is when it matters, and you get the exact same cross product, which you can see right here. Now, a similar theorem, and I'm going to come back and point out how they're different, is the congruent parts of parallel lines. Again, we're talking about 3 or more parallel lines cutting off congruent segments of one transversal, then they are going to cut off congruent segments on every transversal that they meet. And so in this case, if these pieces are all equal, then these pieces are equal, because obviously these are our parallels. That means if I come and draw a transversal like this, that these pieces are all congruent. The key difference between this theorem and the previous one is the distance between the parallel lines. Here, the distance is all the same. The parallel lines are the same distance apart. If you go back to this one, this distance is not the same as that distance. And so that is why if your parallel lines are spaced differently, you get proportional pieces. If your parallel lines are spaced exactly the same apart, you get congruent pieces. Now a few examples. Show that the triangle proportionality theorem is true. So triangle proportionality. So I'm going to compare 4 and 2 to 6 and 3. So I'm going to say 4 over 2. Is that at the same ratio as 6 over 3? 2 over 1 is the same ratio as 2 over 1. Now this is where I want to show you. So this is segment to segment. Now I want to show you small triangle to large triangle. If I would take, as in many problems we've done already, the little baby triangle compared to the larger triangle and set up a proportion that way, I would be talking about 4 over 6 being an equivalent ratio as 6 over 9, as 8 over 12. And if I reduce each one of these, they all reduce to 2/3. And while they are all the same because I've compared triangle lengths to triangle lengths, that is not the same ratio as segment piece to segment piece. So that is why you always have to be careful what it is you're comparing. In this case, it's pretty clear. We could do big triangle to little triangle with 12 plus x, but that's going to require a distributive property when we cross multiply. So let's make things a little easier on ourselves and compare 12 over x to 10 over 15, cross multiply. And when you multiply and divide, I believe we get that x is 18. Now this example is designed to goof you up. The temptation is to want to use the pieces and use that triangle proportionality theorem. But these aren't the pieces that would be proportional. X and 20 represent the top and bottom of those triangles that overlap. And so in this case, we need to use the whole triangle and the baby triangle. So our correct proportion is 6 over x would be equivalent to 10 over 20. And when you cross multiply, you end up with 12. So again, get out your colored pencils, trace it, make sure you're comparing segment piece to segment piece or triangle part to triangle part. This next problem is looking at either the parallel lines and congruent parts or the parallel lines and proportional parts. How do we tell the difference? Given information in the picture. Those two pieces are marked congruent, which then means those two pieces are congruent by that congruent pieces of parallel lines. So I can write two separate equations. 3x minus 4 is equal to 6 minus 2x. So add 2x to both sides, add 4 to both sides, divide by 2. I can come over here and I can set up another set of equations with 5/3 y plus 1 is equal to 3y. I really don't like that 3 in my denominator, so I'm going to multiply both sides of my equation by 3. Remember to do the distributive property. 3 times 5/3, those 3's are going to cancel. I'll have 5y. 3 times 1 is 3. 3 times 3y is 9y. Subtract 5y from both sides. Divide by 4. Y is 3/4. I'm going to do a separate video on this review problem. You can see it in part 2. The last example here that I'm going to do in this video section is to find x. So again, I have multiple parallel lines and a couple of transversals. So are these pieces proportional or congruent? Well, in this case, they are obviously proportional. So I can set up among many, 15 over 10 is going to be equivalent to x over 15, cross multiply, and when you solve, you have 22.5 equals x. Again, I will do a separate video for that review problem and a separate